So for this problem, to find the volume of the largest box that can be made by cutting equal squares of side x out of the corners of a piece of cardboard with dimension 15 by 24 inches. So we have this box and we need to cut these equal squares outside the corners. So observe that if we cut this side and cut this side, so therefore this becomes 15 minus 2x because we cut these two sides. Then if we cut this side and cut this side, so this becomes 24 minus 2x because we also cut two sides. Then to find now the volume, since volume is equal to length times the width times the height, so we can make this one as the width and this one is the length. Then for the height, so if we fold this box and this is now the height and the height is equal to x, so the height is x. So to find now the volume, so the length, so 24 minus 2x times the width, that's 15 minus 2x times the height, that's x. Then to simplify, so 24 times 15, so this is 360. 24 times negative 2x, negative 48x, negative 2 times 15, negative 30x, and negative 2 times negative 2, this is positive 4x squared, then bring down x, then simplify, so this is 360 minus 78x plus 4x squared, then times x, then distribute now this x, so this is 360x negative 78x squared, and this is plus 4x to the power 3. Then we need to find now the derivative of this volume, so v prime, and the derivative of 360x, this is equal to 360, then minus the derivative of 78x squared, so this is 78 times 2, so we have 156, then minus 1 for the exponent, so this is x, then plus, so this 4x to the power 3, the derivative, so multiply 4 times 3, this is 12, then minus 1 for the exponent, so this is x to the power 2, then arrange and reduce. So since these numbers are divisible by 12, so starts with x squared, so we have now x squared, then this 156 divided by 12, so we have 156 divided by 12, so that's 13, so we have minus 13x, then this 360 divided by 12, so we have 360 divided by 12, that's 30, so plus 30. Then we can apply now the quadratic factoring to solve for x and equate this to 0. So x squared is x, and 30, that's 10 times 3, because 10 plus 3 is negative 13, so therefore all negative. So we have now the values for x, so x equals positive 10 and x equals positive 3. Then to find out the exact value for x, so using the second derivative test, so we just need to find the second derivative of the first derivative. So the derivative of x squared, this is 2x. Then the derivative of negative 13x, so this is negative 13. And the derivative of a constant is 0. So for the second derivative, that 2x minus 13, then we can substitute now the value of x. So at x equals 10, so this becomes 2 times 10 minus 13, or this is 20 minus 13, and 20 minus 13, this is positive 7. So if the answer is positive, this is the minimum. Then at x equals positive 3, so this becomes 2 times 3 minus 13, or 6 minus 13, so this is negative 7. And if the answer is negative, so this is the maximum. So therefore, since we're looking for the volume of the largest box, so we're going to use the maximum value for x, and that's x equals 3. So to find out the volume, so we have the length times the width times the height. So for the length, so the length is 24 minus 2 times 3, because x is equal to 3. So this becomes 24 minus 6. So therefore the length is equal to 18. Then for the width, so this is 15 minus 2 times 3, which is equal to 15 minus 6. So therefore the width is 9. So we have now volume equals the length is 18 times the width, that's 9, times the height. The height is x, and since x is equal to 3, so times 3. So therefore the volume equals, so we have 18 times 9 times 3, so that's 486. So the volume is equal to 486 cubic inches.